Hello everyone, I am Samuel Oliveira, a graduate student at the School of Technology at the University of Campinas, São Paulo, Brazil. Research work of the research group for the 5th EPIC conference by the Center for Innovation and Energy Production. The work involves prototyping visualizations as support for the selection of representative models of oil reservoirs and has been developed by Miguel Póvoa, Samuel Silva, and Silva. The selection of representative models uses a user-assisted optimization technique to select a subset of representative models from a set of reservoir models. In the process, the RM Finder is used. RM Finder is used in flow simulation that can only perform simulations on these representative models. Therefore, it is a process that requires fewer computational resources and processing time. It is both a software and an optimization technique for the selection of representative models. In Crosspot, we see representativeness based on a pair of variables. This crosspot was created using RM Finder. The blue dots represent the original models. The black dots are the representative models. RM Finder currently generates reports with representativeness charts. Based on risk curves, executing a complementary cumulative distribution function and also generates cross plots. When analyzing the resulting report from the processing, the user decides whether the solution is truly representative or if a new optimization with new parameters is necessary. Thus, the user must possess domain knowledge in order to evaluate the processing results. Certain demands emerge from that location, such as the necessity to assess different solutions and draw comparisons between them, as well as determining if the RMs are genuinely representative. Another challenge is that the reports are static, lacking interactivity for researchers to explore and scale the tool to accommodate more variables and potential solutions. The research group's proposal is to improve the use of interactive visualizations to enhance this decision-making process, specifically in 2 points. Assist users in analyzing the representativeness of a solution, and aid users in comparing solutions in terms of their representativeness and making informed decisions. Several prototypes were developed and presented in interviews to a group of researchers and specialists. For instance, we have 6 prototypes here. In the initial line, from left to right, we possess the heat map, which signifies the models that are part of a solitary solution. And there is the possibility of him being chosen more in the creation of these solutions in processing. We also possess a multidimensional projection within the risk curve collection. We also possess a visualization heat map that compares the area of the solutions with the original model set for all output variables. The smallest areas are in purple and the largest in green. And finally, the risk curves with envelopes over the set of original models, containing the highest and lowest value of the different selected solutions. On the second line, from left to right, we have a heat map illustrating the representativeness by solution. Then, a scatter plot of variable pairs with bounding box and color coding in clusters to indicate the representativeness of each reference model. In highlight, here we now see the prototypes that will be presented during this work. This, for example, is a heat map of representativeness by solutions, pairs of heat map, and IRMs. In the chart, representativeness is indicated by color. There are 3 colors. Green is good, red is bad, yellow is intermediate in terms of representativeness. In the color of each cell, we see representativeness of the cross plot in the solution. The color of the bars represents the dissimilarity of the root mean squares of the solution's cross plot. The dissimilarity here is calculated based on the Euclidean distance between the scenarios and the RM, closest. On the y-axis, we can observe the variables and their corresponding values. We have the representation of a cross product in all solutions. On the y-axis are the solutions. In this case, we see the representativeness of all cross products of a solution. Every cell of this heat map is clickable, generating the action of providing details about the solution or the variables involved in the solution. The objective of this prototype is to provide an overview of the representativeness of the solutions in relation to the RMs. Now we see how this breakdown would look when clicking on a cell. This, for example, is a cross plot of pairs of variables with envelope in the groups for each representative model. The cross plot was created from the detailed heat map. Some analyses are performed with this prototype. For instance, the wrapper displays the scenarios of each risk management of the cross product. These are the groups. The star symbolizes the risk manager of the scenario groups. The cycle represents the fixed RM in processing. In this case, each one was chosen by the specialist who processed the data entry. Color of each wrapper is calculated by average dissimilarity that scenario has with its nearest RM. The intersection of the lines represents the average of the values for each variable. The analyst perceives how the RMs are distributed in the 4 resulting regions, whether there is a good distribution of the RMs or not. The cross-product can also be generated as a matrix containing all the cross-product of the variables. In this work, we do not see a representation of the graph that is being referred to. The objective of this prototype is to provide an overview of the representativeness of ERMs in the crossplot.
Hello everyone, my name is Miguel. I will continue to show this job. The visual representation shown in this slide is a multidimensional projection. The multidimensional projection is used to create a simplified version of the data set, in which a transformation is made that reduces the original dimension, usually to just 2, while preserving the similarity between the elements. Each point on this graph represented a solution. A solution contains a representative set of models. Points close together can represent that there are a similar solutions according to a distance measured. This distance measured could be the area between risk curves, as shown above. Or we can use another statistical method to check the similarity between 2 curves, such as Kolmogorov-Smirnov. In addition, all the output variables from each of the solutions were combined to calculate this projection. The point highlighted with a different large, in this case size, represented the set of original models. Therefore, points close to it can indicate solution that represented the original model set well. This graph can help the user in the task of finding similarity between risk curves. Is a scenario of scalability between different solutions and variables. In this graph, the user can also apply some filters and some interactivity features. Among them, it's possible to choose a set of solutions and then drill down. In this drill down, the user can analyze the risk curves of the selected solutions. Once the drill down is complete, the user can analyze the risk curves of the selected solutions. One of the options for carry out this analysis is to summarize the set of risk curves. The graph on this slide shows a summary of the risk curves of the solutions selected on the previous slide around the set of original models. This summarization is represented this gray shadow, while the set of original models is represented by the purple dots. This visualization will help the user check the variation of the set of models represented the select solution around the set of original models. Identify whether the select solution are close or heavy variation when compared to the original models. In this slide, I will show a brief conclusion. We are proposing these prototypes to enhance the decision-making of oil engineers when selecting representativity models. At the end of this work, we would like to improve the entire process of development and management of oil reservoirs. To help achieve this goal and follow a user-centered work methodology, we conduct interviews with users to better understand how they make decisions with current and final reports and graphs. At the moment, we have developed our prototypes at an advanced stage of development, with our visual representation present in this work and with interactivity research. Once this stage is complete, we would like to discuss the usefulness of our prototypes with users. We gratefully acknowledge the support of the institutions listed on this slide. Thank you for watching this video. We will be happy to answer any questions or receive suggestions. Thank you.